Hello, and thank you for watching wherever you are in the world. This is Mr. Hill with more eighth grade science, and we're dealing with covalent compounds. We dealt with covalent bonds yesterday, so we're going to keep moving forward. All right, covalent bonding we know happens between two or more nonmetal atoms, and they're using the sharing of the outer electrons of the valence electrons. As we can see here, we have water, CH4, NH3, and even CO2. CO2, of course, is used to make a soda pop or soda, whichever one you want to use to refer to. And then we have, uh, just for clarification purposes, NH3 is ammonia, like CO2 is like H2O is water, and ammonia is used for cleaning as well. Now, what happens before the bonding, as we can see in covalent bonds, is that you have the atoms before they bond and before they come together. So when the atoms, for example, of water, the oxygen molecule, there's two blue dots we can see right here. These two blue dots correspond, or they're matching the same one blue dot that's in hydrogen atoms. And when they bond, they form the covalent bond of H2O. Down below, we have X's being used, and they'll form for NH3. But where those X's are for NH3, just like the two blue dots, or in this case, the four blue dots now for the H2O molecule, you have the covalent bonding forming. Electronegativity deals with how much or how aggressive really one element can pull another element, or the attraction of it, of one element towards another element in a bonding to form a chemical bond. Now, differences in electronegativity that is usually greater than equal to 1.7 is ionic. So HCl, for example, is polar, not polar, excuse me, HC, yeah, it is polar. It's a polar bond, but it is covalent, polar covalent bond. And in that, it has a difference of one because H or hydrogen is 2.2 and chlorine is 3.2. So if you do the subtraction, you'll see a difference of one. So that's right beneath the ionic interaction there. All right, covalent compounds, molecules, their molecular formula indicates the actual number of atoms present. So therefore, H2O, for example, be something like that. So H2O, or even C, CH4, NH3. Those are examples of that. All right, water is polar. It's polar covalent bond. Never forget this. It is very important. Keep that in mind, just with water itself. Also, you have melting points. The thing with melting points is that they're lower than ions. To melt, you are only separating the weak bonds between the molecules, not within. Polar molecules are like mini dipoles. They have higher melting points than nonpolar because they are harder to separate. And we'll talk more about that later on about the mini magnets and dipole moments. All right, polar and nonpolar molecules, they have a different way in which they operate in terms of their classification because polar and nonpolar lets us know if something is closer to it being ionic than not, if you will. And so all of these nonpolar diatomic elements have a really low melting or boiling point. And please excuse the image if you can't see it. But basically, it was just a list, table of things that would show how high or low something is. But typically, covalent compounds have low melting and boiling points. Solubility likes to dissolve, or likes to dissolve, likes to be exact. Polar molecules dissolve in polar solvents as they are attracted to them, like H2O, CHCl3, NH3, etc. Nonpolar molecules dissolve in nonpolar solvents like hexane, CC, CCl4. Calcium chloride, I do believe. Oil and water don't mix. So what happens is that you have something called a molecule head, if you will. And a molecule head looks like this, like a stick figure with no legs, no hands, and nothing like that. So you have the hydrophilic head, and then you have the chain beneath it. So what happens is that oil is attracted to the end of the soap molecule, and then water is attracted to the end of the soap molecule. And when soap and the water mixes with your body, they pull the oil or the soil. Soil is basically a mixture of dirt, sweat, and oil, or oil-based dirt and sweat compounds off your body. And what it does is that one end of the soap molecule is basically bonded with the soil. That's biological oil, if you will, dirt and things like that. And it pulls off your body as the water runs down your body when you take a shower, for example. Because again, the soap is bonding with one end, which is the dirt and oil, and the water is bonded with the soap itself on another end and rinses you off, if you will. And that's how you get clean. Now, I just want to go back to this very briefly here. Dissolve and polar solvent. So polar solubility, a polar substance dissolves, another polar substance adds, a non-polar substance dissolves another non-polar substance. And that's because of the fact that non-polar things will actually balance out and work a lot more efficient because they share anyway versus polar. So when something's polar, it's going to interact a lot more effective because it has the same interaction, if you will, because like attract like in this sense. Right, conductivity. Covalent molecules do not conduct as well as they do not form ions. They are not non-electrolytes, except for acids. Acids are covalently bonded in water, and they will ionize to conduct current. And that is true. Acids are different. Acids are not on, no, they're not on this test or this assignment for right now. They may be later on. Decomposition or decompose. If heat gets high enough, covalent bonds will break down and decompose. Sugar melts first, then it burns, turns into black carbon. So when I talk about the caramelization process, that's when the sugar starts to melt. But as it starts to go closer to the state of burning, is when you get the different types of caramel. Some that's dark, some that is medium, some that's light caramel, dark caramel, medium caramel, different flavors and textures of caramel because it starts to approach the level where it can burn. All right, the virtual work must be done in class, not to be done as homework. This is dealing with eating covalent compounds. This is a write-in critical thinking activity. You feel free to send messages through Schoology or even through my email. And therefore, thank you all for watching and talk to you soon.